Hello everyone, this is Sudhir and welcome back to our maths class. So today I am going to teach you for 9th chapter exercise number 2, question number 2. So what about the question number 1? The question number 1 we have some multiple choice questions. So which we have discussed already in the previous classes like theorems we have discussed theorem 9.1 and theorem 9.2 and similarly 4 statements we have discussed in the previous class. So based on that theorems and statements, so if you know the concepts are very well, you can complete that first Roman or multiple choice questions. Okay. Now here is the question number 2. Of course, this question number 2 also it's almost all similar to the statement number 2. So in the statement number 2, we have discussed about the two concentric circle. So here also we have the concentric circle only. So what is the concentric circle? Concentric circle means the circles which having the same center, right? So here I am going to take the center O. Now here is a circle, a smaller circle. And this is the larger circle, right? So the smaller circle radius is 3 centimeter given. Smaller circle radius is 3 centimeter. Larger circle radius is 5 centimeter. The larger circle I am taking here this one. This is the radius of the larger circle. Okay, so smaller circle radius I am going to take as OP, and the larger circle radius I am taking as OA. This is 5 centimeter given. Now, what we should find in this problem? Find the length of the chord of the larger circle which touches the smaller circle. The length of the chord means a line segment which join the 2 points on the circle, but the chord is it should be touched to the smaller circle here. So that means we should draw like this. Now this is the chord. AB is the chord of a larger circle. Similarly, AB is the tangent to the smaller circle, right? Why it is tangent? It should touch at only one point. That point at P. So this P is called a point of contact. Now here it will form their 90 degrees because the radius and the tangents makes 90 degrees at the point of contact. So that is the logic here. And what we have to find in this problem? Length of the tangent or length of the chord. This total length we have to find. How can we find? If you observe here, it is a right triangle. It is a right triangle OPA. In a right triangle OPA, according to the Pythagoras theorem, you can write OA square is equal to AP square plus OP square. So from this we can find AP. So you will get AP. Now AP means 2 times of AP. Why 2 times? This line actually in the previous means in the last class also we have discussed in statement number 2 as well as you know very well a radius which is drawn perpendicular to the chord is bisect the chord. Okay, a radius which is drawn perpendicular to the chord is bisect the chord. It is a very important point here. So it's bisecting, then AP is equal to PB, both are the same distance. When you know the AP, then to find the AB take 2 times, then you will get the answer. For example, 5 and 3 in here definitely will get the 4 because this 3, 4, 5 are called the Pythagoras triplet, right? In a right triangle, according to Pythagoras theorem, we have 3 and 5 in here, definitely we will get here 4 only. Then what is the total AB length here? 2 times of AB, that is a 4 into 2 is equal to 8 centimeter. So we can discuss now step by step. What is given in the problem? In the answer, you can take the smaller circle as C1, larger circle as C. Okay, so let C1 and C2 are 2 concentric circles. 2 concentric circles with center O. With center O. And similarly, OP is the radius of circle C1. OP is the radius of circle C1 and OA also is a radius of circle C. Okay, now AB is a chord of larger circle and AB is a tangent to smaller circle. Yes, listen here. AB is the chord of the larger circle, but the same AB is the tangent to the smaller circle. Why it is tangent? Because here given find the length of the chord of a larger circle which touches the smaller circle. Touch means it's a tangent, right? So what we will get here? OP is perpendicular to AB. Since radius and tangents makes 90 degrees, right? Radius and tangent makes right angle at point of contact. Point of contact. Okay. So now in right triangle OAP, in right triangle OPA, so OA square equal. See, OP is the radius of the smaller circle, that is equal to, this is 3 centimeter, and OA is 5 centimeter. So OA square is equal to, this OA square is equal to OP square plus AP square. So OP square plus AP square. OA square is, this is the 5 square equal to, what is OP here? 3 square plus AP square. So this is 25. 5 square equal to 25 is equal to, this is 3 square 9 plus AP square. Then send this one here. We have AP square is equal to 25 minus 9. So AP square is equal to 16. Then AP equal to root of 16, that is equal to 4 centimeters. So AP is equal to 4 centimeters we got now. So we know that here AP is equal to 2 times of AP. So why here we can write the reason also why AB is equal to 2 times of AP. The radius, a line which run from center, the line which run from center to perpendicular to the chord is bisect the chord. That is the logic. Okay. Otherwise, in statement number 2 also we have discussed the same logic. When we have taken it is a chord of the big circle, and at the same time it is a chord to the smaller circle, then these two are equal. How it is? If you join this one here, see what we have discussed in statement number 2. If you join this one, these two triangles are the congruent. How? It's a common side of the both triangle. Here 90 degrees, 90 degrees, and the radius are equal in the two circles. I mean, yes, completed in one circle, so radius are equal. According to RHS congruency, the two triangles are the congruent. When the two triangles are the congruent, according to CT, we can say that two sides are equal. That means AB is equal to PT. So two logics are there here. So logic number 1, a line which should run from center to perpendicular to the chord is bisect the chord. It is a very simple. Otherwise, if you want to write from statement number 2, you can prove it is a congruent triangle and then you can write it. So very simple point you can write here, a line which should run from center to perpendicular to the chord is bisect the chord. Then 2AB we can write. So AB is equal here 2 times of 4, that is equal to 8 centimeter AB. Therefore, what is the chord here? Length of the chord is 8 centimeter. So this is the most important question, children, for the board examination for 4 marks. I mean, this is the essay type question. Okay. So I hope you understood this question. So next question will continue now. Here is the next question from the same exercises, that is, prove that the parallelogram circumscribing a circle is a rhombus. So statement number 4. In statement number 4 we have discussed. So quadrilateral is there. The quadrilateral. So circle is circumscribing in a quadrilateral. Then we proved there some conditions, right? The same model this one also. What we have to prove? So ABCD is a parallelogram and circle is there here. So the circle touch this parallelogram, the sides of the parallelograms at PQRS. Then what we have to prove? This ABCD is a rhombus. Okay. So generally we are taking if it is a parallelogram. So if it will satisfy this condition, then finally we have to prove it is not a parallelogram, it is a rhombus. So what is a parallelogram and what is a rhombus? Parallelogram means opposite sides are equal. Okay, so main point we are discussing, not core properties. Parallelogram means opposite sides are equal. Rhombus means all sides are equal. That means their adjacent sides also equal. Okay, parallelogram means opposite sides are equal. Okay, rhombus means all sides. All sides mean their adjacent sides are also equal. So we have to prove that finally their adjacent sides are equal. Okay, so how we can discuss now? Okay, it is. We can take like, okay, given, what is given in this? ABCD is a parallelogram. ABCD is a parallelogram. Required to prove. What we have to prove? ABCD is a rhombus. Is a rhombus. See, ABCD is a parallelogram, mean AB equal to CD, AB equal to CD. Similarly, BC equal to DA. Okay, so opposite sides are equal. So ABCD rhombus. That means what we have to prove here, AB equal to BC. We have to prove AB equal to BC. To prove this, in proof what I am going to take. See, if it is a circle, now AB is a tangent, BC is a tangent, CD is a tangent, and DA is a tangent, because the circle these sides are touch the circle at only one point, like PQRS. Okay, so that these are the tangents. Now, if it is tangents, then these two are equal, because if it is a circle, consider this is the exterior point. Okay, so from theorem 9.2, what you have learned there. The tangents are drawn from external point to the circles are equal, so that these two are equal. Okay, so now the point we are going to write here. So AB from the figure, AB, BC, CD, DA are tangents to the circle. Okay, and those all are touch the points at PQRS. Okay, so it's a tangent. So therefore, what we write now, AB is equal to AS. The reason is since the tangents are drawn from external point to the circles. External point of the circles are equal. Okay, so AP is equal to AS, AP is equal to AS. Similarly, BP is equal to BQ. And this is a condition number 1. Now I am going to take the BP is equal to BQ. It's a condition number 2. Okay, and here CR is equal to CQ. CR is equal to CQ. The reason is the same reason. Now DR is equal to DS. DR equal to DS. This is number 4. So adding 1, 2, 3, 4. Add 1, 2, 3, and 4. We have AP plus BP plus, here AP plus BP plus CR plus DR. CR plus DR equal, this side BQ plus CQ plus AS. AS also is there here. So AS plus BQ plus CQ plus DS. Okay. So now you can observe AB plus BP equal. Here this is AB plus BP is equal to what we write here, that is equal to AB plus BP is equal to AB plus, and what is CR plus DR? Here CR plus DR, that is equal to C is equal to, similarly BQ plus CQ. BQ plus CQ is equal to BC plus AS plus DS. AS plus DS is equal to AB. Actually, in statement number 4, we proved this one. If it is just a quadrilateral, this is your answer. But it is a parallelogram given, so that in a parallelogram, opposite sides are equal. AB is equal to CD. So instead of CD, I am going to write AB now. So AB plus AB I can write. Now BC plus, instead of AD or DA, we can write here BC. So AB plus AB, this is 2AB. BC plus BC, this is 2BC. 2 cancel on the both sides. Then we have AB is equal to BC. AB equal to BC means it is a rhombus. So what we put here, adjacent sides are equal. So we can write here. So adjacent sides are parallelogram. Adjacent sides of parallelogram are equal. So it is rhombus. So it is roundness. That's it. So it's a very important question for the board examination. So I hope you understood this one. And here is the very interesting question, that is one triangle has given. In this triangle, this is the circle, and the BD is given 9 centimeter, DC is 3 centimeter, and the radius is here. This one also 3 centimeter. Radius also given in the problem 3 centimeter. A triangle ABC is drawn to a circumscribe. Circumscribe means this is inside of the circle. So the sides of the triangle should touch the circle at a point. So this circle and this side should touch at a point, that is D, and here it is E, and this is F. Okay. Now you can observe. So what we have to prove here, and the radius given 3 centimeters, such that the segments BD and DC, into which BC is divided by the point at a point of contact. So this is a point of contact now. So D is a point of contact they have given. Point of contact given. Now here we have a right angle. So it's a radius and it's a side. Radius and side, but D is the point of contact they have given. So that means BC is the tangent now. So tangent and radius makes 90 degrees. So that I have taken here, it is a 90 degrees. And so still here the length 9 centimeter and 3 centimeters are respectively. Find the side of AB and AC. Okay. So very simple here. If it is a tangent, and because D is the point of contact and it is external point of the circle, from theorem 9.2, the tangents are drawn from external point of the circles are equal, so that this is 9 centimeter. This one 3 centimeter means here also 3 centimeter. Now this length I am going to take x. We don't know this one, so x, and here also we have x centimeters. Okay. Now it's a 90 degrees. Okay. Now I am going to draw a line here. OE. I have joined here OE. This is 3 centimeter and 3 centimeter, and here a right angle. So adjacent sides are equal and having here 90 degrees. Adjacent sides are equal. Okay. Adjacent sides are equal, and even this one also is 3 centimeter and this one also radius. So 4 sides are equal now, 3 centimeter, and here we have 90 degrees. So that what is this? It is a square, and in a square all angles are equal. Mean here also we have 90 degrees. Here mean this point. Here we have 90 degrees. Now what type of triangle it is? ACD. Yes, it is a right triangle. Right triangle means what concept we should take? Pythagoras theorem, right? So by using the Pythagoras theorem, by simplifying, we can find out what is the value of x, and by substituting x here, so we will get what is the AB length and what is the AC length. So how we can take it? The solution I am going to take. So from the figure, D is point of contact. D is point of contact. So therefore this is BC, right? So BC is tangent. Okay, tangent to the circle, and this BC is the tangent to the circle, and OD is the radius, and OD is a radius. So therefore angle ODC equal to 90 degrees. ODC equal to 90 degrees. Since we can write here radius and tangents makes a right angle where at point of contact. That point also you can write there. So ODC is equal to now 90 degrees. Now you can observe OD equal to OE is equal to 3 centimeters. Since those are the radius, already given radius here 3 centimeters, right? And CD is equal to C. CD is equal to 3 centimeters. Since what is the reason here? Length of the tangents are drawn. Length of the tangents are drawn from external point to the circle. external point to the circles are equal. So CD is equal to C. Finally what we do, OD is equal, OE equal, CD equal, CE. So all sides are equal, and here ODC is equal to 90 degrees and angle ODC equal to 90 degrees. Therefore, what is this? ODCE is a square. Therefore, what we can say here now? Angle ACD or angle ECD. That is equal to 90 degrees. So therefore, what we conclude now? Triangle ACD is right triangle. It's a right triangle. Okay, still we have this solution. So finally we proved this is a right triangle. So from Pythagoras theorem, we can write AB square is equal to AC square plus BC square. AC square plus BC square. But here we don't know what is the total length of AB, so that we can take here AF is equal to AE is equal to X. So let AF is equal to AE equal to X centimeters. So AB means the total we can get here X plus 9 whole square. AC, that is X plus 3 whole square, plus this one 9 plus 3 is equal to 12. BC is 12 square. Okay, so this is in the form of A plus B whole square. How we write A plus B whole square? We write A square plus 2AB plus B square equal X square plus 2 into X into 3 plus 3 square plus 12 square is 144. 12 square is 144. Now this is X square plus 9 2's 18X plus 81 equal X square plus 2 3 6X plus 3 square is 9 plus 144. So we can cancel X square on the both sides, and here we have 18X plus 81 equal, this is what, 6X plus, so by adding both we get 150. So just transpose these two here. We have then 18x minus 6x is equal to 153 minus 81. So what is this? This is 12x. 18 minus 6, 12x is equal to 153 minus 81. What we get? 153 minus 81. So 72 we can get it, right? So 72. X is equal to 72 divided by 12. 12 1, 12, 6. So x is equal to 6. If x is equal to 6 here, what is the length of AB? Then AB equal to, AB is x plus 9. So that 6 plus 9 equal to 15 centimeters. Similarly, AC is x plus 3. So we write here x is 6 plus 3 is equal to 9 centimeters. Got it? So this is the total solution of the problem. They asked about the AB and the AC. B is already given, that is 9 plus 3 is equal to 12 centimeter only. So we should find in this problem AB and AC. So what we did in this problem? It's a circle and it is a point of contact given. Point of contact means here will form a 90 degrees. And one more point here is 3 centimeter. This is 3 centimeter because it is a point exterior of the circle. The length of the tangents are drawn from external point to the circles are equal. So that this is 3 centimeter. And radius also given 3 centimeter here. So this is 3 and 3 centimeter. Finally 4 sides are equal. This angle is 90 degrees, so that it is a square. If it is a square and this one is a 90 degrees now, right? If it is a square and here it is a 90 degrees, then it is a right triangle. So I have used the Pythagoras theorem concept here. So then by simplifying I got it x value 6. Then that 6 plus 9 is equal to 15 and 6 plus 3 is equal to 9 centimeters are the length of the, sides of the triangle. Okay, so I hope you understood this question also. So one more question we'll discuss now. Next question number 8 from the same exercises. So middle that question, a few questions like 5, 6, 7, those are the constructions. So constructions we'll discuss in the next class. Okay, So the question number 8, this is the last step problem from this exercise. Okay, so in a right triangle ABC, a circle with the side AB as diameter is drawn to the intersect the hypotenuse AC in B. So observe the figure also given in the question only. So this is a circle and AB is the diameter of the circle, O is the center of the circle. So in a right triangle ABC, so what type of triangle it is? Right triangle they have given. In a right triangle ABC, the circle with the side AB as the diameter, so AB as the diameter is drawn to intersect the hypotenuse. AC, it's a hypotenuse, right? Right angle opposite side is called the hypotenuse. So to this hypotenuse, this circle intersect at P. Okay. So prove that the tangents to the circle at P, prove that the tangents to the circle at P, means this is the tangent, is bisect the base. So it will be divided into two equal parts. So this is a tangent of a circle. This tangent of a circle will bisect BC, mean we have to prove here BQ is equal to QC. So how it is? Just you can see. What is the given in the question? What is the given? ABC is a right triangle. Triangle ABC is right triangle. Right angle at where? D. And AC is the hypotenuse. P is the tangent they have given. Okay, so RTP, what we have to prove? We should prove that BQ is equal to QC. BQ equal to QC. Okay. Now proof. How we can prove this? Here this angle we have 90 degrees because it's a diameter, means this is the semicircle. It's a semicircle now. So angle in a semicircle is a right angle, right? So we can write angle angle APB equal to 90 degrees. The reason is since angle in a semicircle, right? Angle in a semicircle is right angle. Next step, if it is a 90 degrees, now what about this angle? Angle APB plus, mean this angle APB plus BPC equal to 90 degrees because of those are the straight line. It's a straight line, okay? Or linear pair also we can call it. So it's a straight line, this is 90 degrees means, so BPC also will get 90 degree here, okay? So this is 90 degrees plus angle BPC equal to 180 degrees. So angle BPC equal to 180 minus 90, then angle BPC equal to 90 degrees. So finally BPC means this total, this one also now, here we have 90 degrees, right? And one more important point here, angle ABC, right angle. Angle ABC 90 degrees because it's a right triangle already given in the question. This is a right triangle, okay? So that angle ABC is a right triangle. So from angle sum property, angle ABC plus BAC plus angle AC equal to 180 degrees. The reason is angle sum property. So what is ABC here? 90 degrees plus BAC plus angle ACB equal to 180. So angle BAC plus angle ACB equal to 180 minus 90. So angle BAC plus angle ACB equal to 90 degrees. Just you can follow here how many 90 degrees we got. Here one condition, that is angle BPC. Angle BPC means this angle is right angle, and here angle BAC plus ACB means sum of these two angles, BAC plus ACB also 90 degrees. Now what we will do? This is equal to the next step. Okay, so we'll continue now. So by using this concept, so one more time, BPC we got 90 degrees, angle BAC plus angle ACB, BAC plus angle ACB means sum of these two angles also 90 degrees. Now we'll continue so how to solve this problem. So finally we got these two conditions. So BPC is equal to 90 degrees and sum of these two angles, that is BAC plus angle ACB is equal to 90 degrees. So from these two conditions we can write angle BPC equal to angle BAC plus angle ACB. Okay. So how this BPC can write? This is BPQ plus QPC. Angle BPQ plus angle QPC we can write from here. So that means angle BAC plus angle AC. Okay. So this is one of the condition. Now we know that these two angles are equal. These two angles are equal. Angle BAC equal to angle BPQ. Why this is equal? This is called alternate segment angles. We have alternate segment theorem. So in the concept, so alternate segment theorem. According to alternate segment theorem, these two angles are equal. Okay. So since alternate segment angles, so that those two are equal. Therefore, now I am going to write. So I am going to cancel from this condition number 1 you take, and it's a condition number 2. From 1 and to 1 we can say here BAC and BPQ both are cancelled because of the two are equal, right? So from 1 and 2 we can write now angle QPC equal to angle AC. What is QPC? QPC is this angle, okay? And what is AC? This angle. So now these angles are equal. Finally we proved these two angles are equal. Okay. Now you can take that in triangle PQC, we proved angle QPC equal to angle ACB. So when the two angles are equal, so in a triangle the two angles are equal means it is isosceles triangle. So when the two angles are equal, these opposite sides are equal. So which is that QPC mean this one? QPC opposite is QC. So we write here QC equal to ACB mean this angle opposite side is PQ. This is PQ. It's a condition number 3. Okay. And one more condition I am going to take, that is this is the external point of a circle. Now these two are the tangents, right? So we write here BQ is equal to PQ. The reason is since the tangents are drawn from external point are equal. So that is theorem 9.2. From the theorem 9.2 we write these two are equal now. So take this is the condition number 4. Now from 3 and 4 what we conclude? From 3 and 4 you observe here QC is equal to PQ but PQ is equal to BQ. Therefore BQ is equal to QC. BQ is equal to QC. That means these tangents divides are bisect. Therefore tangent divides a tangent bisect PQ. So hence proved. This is what they asked in the statement. Okay. So finally we proved here these two are equal. That means this one, this tangent divides. I mean not divide, bisect PQ. Bisect means so it divided into two equal halves, right? So I hope you understood this model question. So that's the matter today. So take care. Bye and Jai Hind.